In July 2025, deep inside the southern reaches of Everglades National Park, a research team monitoring a tagged Burmese python noticed something wrong with the signal. For days, the transmitter had moved the way it always did, a slow, deliberate crawl through wetland vegetation consistent with a 17-foot predator hunting for its next meal. Then, without warning, the movement pattern changed. The signal began traveling fast, in a straight line, covering ground no python moves across on its own. When the team finally reached the coordinates, they found nothing. No snake, no carcass, no sign that a massive apex predator had ever been there at all, except for the tracking device itself, which was no longer where a python's stomach should have been. It was moving through the swamp inside something else, a predator that had eaten a predator. And that single moment, a transmitter behaving in a way the researchers could not explain, became the first thread in a discovery that would force scientists to rethink everything they believed about the trajectory of one of the worst ecological disasters in American history. Because what the cameras deployed after that signal anomaly eventually captured was not the continuation of a slow-motion collapse everyone had been bracing for. It was something almost nobody expected in an ecosystem that had spent 40 years being systematically emptied of life. To understand why that single tracking signal mattered so much, you have to go back to where this crisis actually began, because the story of the Florida Everglades is not a story that starts with hope. It starts with catastrophe, and it starts quietly, the way most catastrophes do. Sometime in the early 1980s, a small number of Burmese pythons, massive constrictors native to the tropical forests and river valleys of Southeast Asia, were released into the sawgrass and shallow water of South Florida. Some escaped during storms that damaged breeding facilities. Many more were deliberately let go by exotic pet owners who had purchased a hatchling python without fully understanding what that hatchling would become. Burmese pythons do not stop growing at the size they are sold at. They grow across years and decades until they reach lengths that can stretch past 17 or 18 feet, with bodies as thick as a grown man's thigh and jaw structures capable of unhinging wide enough to swallow a full-grown white-tailed deer whole. When the snake outgrew the tank, outgrew the spare room, outgrew the life its owner had imagined for it, many owners did the same thing. They drove to the edge of the Everglades and released it into the wild, assuming the swamp would simply absorb it the way it absorbed everything else. The Everglades did more than absorb it. The ecosystem welcomed it like nothing else could have. Warm year-round temperatures, dense tangled vegetation, an abundance of unsuspecting prey, and a landscape structured in a way that turned these ambush predators into ghosts. Trained field biologists with decades of experience in the swamp have walked within 3 feet of a full-grown Burmese python without ever seeing it, its camouflage blending so completely into the sawgrass and shadow that the animal effectively disappears in plain sight. By the 1990s, multiple generations of pythons were breeding inside Everglades National Park, invisible to almost everyone, multiplying in silence. By the early 2000s, wildlife managers running routine field surveys started noticing something deeply unsettling. The mammals were vanishing, not declining. It was erasure, moving through the food web one species at a time. The disappearance of the mammals did not stop with the mammals. It cascaded. Florida panthers, already among the most endangered big cats in the Western Hemisphere, with a population that had been driven down to roughly 20 individuals in the 1990s before intensive breeding and conservation programs slowly rebuilt their numbers, found their prey base collapsing beneath them just as recovery efforts were gaining ground. Hawks and owls that had hunted these marshes for generations began circling over landscapes with almost nothing left to catch. Even the American alligator, an apex predator that had ruled these waters for tens of millions of years, found itself competing directly with an animal it had never evolved alongside. And, in some encounters, according to researchers who have since documented these interactions, the alligator was not always winning. Beneath the headline-grabbing spectacle of giant snakes swallowing deer, a quieter, less visible catastrophe was unfolding. The insects that fed the birds that controlled the insects, the small mammals that aerated soil and dispersed seeds and cycled nutrients through the landscape, the entire invisible machinery that keeps a wetland ecosystem functioning, was breaking down piece by piece. The Everglades was not simply losing individual animals, it was losing its capacity to function as the Everglades at all. For a long time, the institutional response to this collapse was strikingly slow. Wildlife officials did not formally confirm a breeding population of Burmese pythons in Everglades National Park until the year 2000, and by that point, scientists now believe the invasion had already been established for close to 2 decades, with a population that had already grown into the thousands. Organized removal efforts took years longer to materialize. The Florida Python Challenge, the public hunting competition that would eventually become the most visible symbol of the fight against the invasion, did not launch until 2013. Even then, the results exposed just how outmatched early efforts were against the true scale of the problem. In that first challenge, roughly 600 participants spent 10 days combing the swamp and came back with 68 snakes against a population some researchers estimated at tens of thousands of individuals spread across a landscape of more than 1 million acres. The math was never encouraging. The core difficulty was never really about manpower. It was about detectability. Burmese pythons are so well camouflaged in Everglades terrain that the standard survey tools used against other invasive species, transect walks, spotlight counts, population sampling, proved almost useless against an animal that can lie motionless for days inside vegetation that matches its skin pattern almost pixel for pixel. Researchers tried nearly everything to compensate. Scout snakes, male pythons fitted with radio transmitters and released to lead hunters, straight to breeding aggregations during mating season, when they instinctively seek out females. Detector dogs trained to pick up python scent in dense brush. Even robotic decoy rabbits, engineered to lure a hunting python into range and trigger a GPS alert the moment it struck. Every available tool was thrown at the problem, and for years the removal numbers stayed frustratingly, stubbornly small relative to the scale of what was actually out there in the swamp. Then, starting around 2024 and accelerating sharply through 2025, something changed, and it changed on two fronts at once. The first shift was in the raw removal numbers. Between May and July of 2025 alone, wildlife teams pulled 1,122 pythons out of the Everglades, compared to 343 removed during that same 3-month window the year before. In July 2025 alone, teams removed 748 pythons, more than the total for the entire previous year combined. The Florida Fish and Wildlife Conservation Commission's Python Action Team, working alongside contracted hunters and in partnership with a Miami-based biotech company called Inversa, had roughly tripled the removal rate within the span of about 2 years. Management workload for the agency dropped by close to 90% even as output surged, a sign that the process itself had become dramatically more efficient, not just better funded. Hunter pay rose alongside performance, and since organized removal programs began in the year 2000, more than 23,000 Burmese pythons have now been taken out of the Florida landscape, with 2025 setting records that would have seemed almost fantastical only a few years earlier. But the removal totals, staggering as they are, were never really the center of this story. The center of the story is what began happening inside the ecosystem itself as those numbers climbed, and that is the part almost nobody, not the researchers, not the wildlife managers, not the conservationists who had spent 30 years documenting decline, saw coming with any confidence. It starts with that anomalous tracking signal from earlier in the year, the python transmitter that suddenly began moving fast and directly through terrain no snake travels that way. For weeks, the footage showed nothing unusual. Raccoons moving along the marsh edge, wading birds, probing the mud for food, small reptiles slipping through the shallows. Then one camera captured something far larger, passing directly through the same spot where the tracked python had disappeared. That detail rewrites a significant piece of the narrative that had defined this crisis for 2 decades. Burmese pythons are extraordinarily capable predators in their own right, but confrontations between the two giants of the Everglades do not always end the way the popular narrative assumed. In certain conditions, particularly in deep water at night, where an alligator's advantages in aquatic combat, its bite force, its ambush speed, its ability to drag prey underwater and hold it there, can fully express themselves, the python is not always the one that walks away. The American alligator is a species that has existed in something close to its current form for tens of millions of years, that survived the asteroid impact that wiped out the dinosaurs, that has occupied the top of this particular food web since long before the first human beings arrived on the continent. What the evidence increasingly suggests is that the alligator has, in effect, been quietly assessing this newcomer for years and has, at least in some encounters, decided the python is simply another large animal that can be ambushed, overpowered, and consumed like anything else in its territory. That single discovery was only the beginning of what the deep swamp cameras were about to reveal, because as the removal numbers climbed through 2025 and into 2026, trail cameras 2, positioned in the most remote, most heavily impacted sections of the park, the areas that had been emptied of mammals the longest and had suffered the most severe collapse, began documenting something researchers were not prepared for. Marsh rabbits appeared near the southern boundary of zones where intensive python removal had been ongoing. Raccoons showed up on camera in sections of the park that had not logged a single raccoon sighting in 10 years or more. Distinct tracks and body outlines consistent with animals that scientists had all but written off in those specific areas began turning up across multiple cameras over multiple nights, a pattern too consistent to dismiss as a fluke. Behind those sightings sits an enormous, grinding, largely invisible effort. The Conservancy of Southwest Florida's science team, using radio telemetry on roughly 40 tagged male pythons functioning as scout snakes, removed an additional 4,100 Burmese python eggs from the ecosystem in a single breeding season. Sit with that number for a moment. Each one of those 4,100 eggs represents a python that will never hatch, never grow into a 15-foot ambush predator, never spend the next decade and a half systematically working through the mammal population of its territory. When that kind of removal compounds season after season, alongside the record adult removal numbers from 2025, it begins to open something researchers describe carefully as ecological space, measurable gaps in a predator pressure that had, for 40 years, been total and unrelenting. And into those gaps, according to people close to the ongoing fieldwork, something appears to be moving back in. None of this amounts to proof of recovery, and every researcher involved is careful to say so. Recolonization is slow, uncertain, and entirely dependent on factors that are still poorly understood. The survival of source populations in areas that were never fully emptied, the existence of intact habitat corridors connecting those refuges to the recovering zones, and conditions on the ground capable of actually sustaining animals that attempt to move back in. None of that is guaranteed, and all of it remains fragile. But the cameras are showing something, and what they are showing is not the continuation of the collapse everyone had spent 30 years bracing for. The story does not resolve neatly from here, because the removal effort, however record-setting on paper, is still operating well behind the underlying biological reality of the invasion. Burmese pythons continue to disrupt the ecosystem not only through direct predation, but through outcompeting native predators for the same shrinking pool of prey. And juvenile pythons face essentially no natural predators during their first few years of explosive growth, giving the population a running head start every single breeding season. Range maps released through 2025 show the python's territory continuing to expand beyond its original South Florida stronghold, moving into new counties and new habitat types. The invasion is not contracting uniformly across the landscape. It is being pushed back hard in some intensively managed zones, held roughly steady in others, and actively still expanding in areas that lack the removal infrastructure that took decades to build in the park's core. The Everglades spans nearly 1.5 million acres, a landscape larger than some entire countries. And the python remains a master of disappearing into exactly that kind of terrain. Layered on top of the python crisis is a second, quieter problem that the same cameras are now beginning to document with increasing frequency. The Burmese python was never the only invasive species establishing itself in this ecosystem, only the one that captured public attention. Invasive melaleuca trees, growing at rates of 3 to 6 feet per year, form dense monoculture stands that choke out native vegetation, disrupt natural water flow across the wetland, and dramatically increase fire risk during dry seasons. Blue tilapia, a fish species native to Africa, has spread through Everglades waterways, consuming the aquatic vegetation that native juvenile fish depend on for cover and food. And now, for what researchers with the University of Florida's Croc Docks Wildlife Research Team believe is the first time ever documented in the Everglades proper, a spectacled caiman nest has been found and photographed. The spectacled caiman, a crocodilian native to Central and South America, almost certainly another released or escaped exotic pet, has apparently found the conditions of South Florida favorable enough to begin breeding inside the same fragile system that is already managing a python invasion, a decades-long mammal collapse, and a water flow crisis decades in the making. Roughly 8 million Floridians, close to 1 in 3 residents of the state, draw their drinking water from the Biscayne Aquifer, which sits directly beneath the Everglades and depends entirely on the health and function of the wetland above it. The same biological and chemical processes disrupted by the collapse of the mammal population, by the spread of melaleuca, by the loss of native vegetation to invasive tilapia, are the same processes responsible for filtering and slowly releasing the water that keeps that aquifer functioning correctly. In June 2024, a tropical weather system dropped a staggering 27.95 inches of rain on Big Cypress National Preserve in just 4 days, triggering flooding across South Florida that caused more than $100 million in damage. The Everglades, shaped over thousands of years specifically to absorb, filter, and gradually release exactly that kind of extreme rainfall across its vast, shallow basin, is now performing that function at a fraction of its original capacity, because the Everglades that exist today covers less than a third of the territory it occupied before 20th century drainage and agricultural development began carving it apart with canals and levees. Into an ecosystem already operating under stress no natural system was ever designed to withstand comes the python, and now the caiman and the melaleuca and the blue tilapia, compounded further by rising sea levels along the coastal edge and increasingly intense hurricane seasons driven by a warming Gulf of Mexico. What the cameras in the deep swamp are ultimately documenting is not one story but two running in parallel. The first is the story of an enormously difficult, slowly accelerating effort by hunters, scientists, and state agencies to claw back control of the python population across the accessible portions of the park, and the first faint, still uncertain signs that this effort may finally be opening space for display. The relationships that collapsed, predator to prey, pollinator to plant, seed disperser to forest floor, cannot be restored automatically the moment predator pressure eases. That web has to be rebuilt piece by piece, and no one currently knows exactly how long that rebuilding takes, or whether every piece needed to complete it has actually survived. Restoration efforts extending well beyond python removal are already underway and moving on their own decades-long timeline. The Everglades Agricultural Area Reservoir Project, one component of a broader multi-billion-dollar federal and state restoration effort, is designed to eventually reconnect Lake Okeechobee to Florida Bay, allowing clean, fresh water to flow south through the system for the first time in generations, instead of being diverted east and west through canals built for agriculture and flood control. That single infrastructure project alone, long delayed and enormously expensive, represents only one piece of a much larger restoration puzzle involving multiple state and federal agencies, billions of dollars in committed funding, and a completion timeline stretching across decades rather than years. All of these processes need to move forward roughly simultaneously, across a landscape of 1.5 million acres that sits surrounded on three sides by one of the fastest growing human populations in the entire country. That is the scale of the undertaking, sitting behind every piece of footage now emerging from the deep swamp. A raccoon crossing a marsh where no raccoon had been recorded in a decade. A rabbit track pressed into soft mud near open water. Movement patterns suggesting mammals are beginning to test the boundaries of zones where python pressure has finally begun to lift.